I'm going to turn the floor over to Sue Buto and Steve Aichele for their presentation. And thank you very much for doing this presentation for us.
Great, thank you so much, Keith. We really appreciate the invitation. Next slide. So I kind of like to start with a grounding exercise in the history of topographic mapping with the USGS. Starting in 1884, we have the authority to map the nation, topographic mapping with elevation and hydrography in an era where we collected data to make our maps. And then at the advent of the digital age, we started to harvest data from those maps to develop NHD and our early elevation data. And that's an era where USGS maps made our data, and our elevation and hydrography data diverged from each other and were no longer aligned as they are in our topographic maps. And so now we're in a phase where we are collecting high accuracy 3D elevation program data, and we have the ability now to derive new aligned hydrography data from that. So we're moving back into an era where we are again collecting data to make our maps. Next slide. So I want to quickly introduce the 3D National Topography Model as sort of the overarching concept for where we're headed in the National Geospatial Program. And the 3D NTM, or 3D National Topography Model, comes out of the vision that USGS and NOAA share for a 3D nation, which is a vision for a continuous topographic surface from the depths of our waters to the peaks of our mountains. And we're headed there with NOAA having authority over ocean mapping and USGS over terrestrial mapping in this integrated 3D model that we're calling the 3D Topography Model. So it begins with us completing our national baseline data sets, and I'll focus on the 3D elevation program portion of this. We're at the end of FY21, federal fiscal year 21, we were at 84% of the nation complete, and we're on track to add quite a bit more square mileage this fiscal year. Hopefully we'll have numbers out soon. And then we're developing our next generation programs that will feed into the 3D National Topography Model. And that is the 3D Hydrography Program that we're talking to you today about. And then designing the next generation of 3DEP. What do we do once we have complete baseline coverage for the nation? And then moving into this idea of an integrated 3D topography model where we have aligned hydrography and elevation data and inland bathymetry. Next slide. So our current approach to our national hydrography data sets has a long history. The data sets that we're talking about as our current data are the National Hydrography Data Set, the Watershed Boundary Data Set, and the NHD Plus High Resolution. And these data sets combined are arguably the most comprehensive data depicting the nation's surface waters. And the NHD and the WBD have long leveraged local knowledge and direct updates to our data through a stewardship program with participants from 41 states and Washington, D.C. It's a great program. One issue that happens with the program is that we have a decrease in national consistency over time because some stewards have more resources to bear on the data and update the data, and other areas either don't have a steward or stewards with not enough resources to improve their data. And the other key thing here is that our NHD surface water features don't align well with our highly accurate 3D elevation program data. Next slide. And so hydrography derived from that highly accurate elevation data offers us a solution, and that is where we're headed with the 3D hydrography program. So the goal of the 3DHP is to acquire new hydrography that is standardized to align with our 3DEP data that will support national down to local level applications and analyses, and also support sharing water data as the geospatial framework that underpins the Internet of Water. Next slide. And just briefly, the Internet of Water comes to the premise that there's a lot of water data that's collected by a variety of agencies and entities across the nation, but we lack a systematic way to organize, search, and discover it. So there's a federal consortium of partners who are developing a geospatial information infrastructure that will allow for a federated sharing and discovery of water information in the context of the stream network. And the 3DHP is intended to be the geospatial underpinning or that stream network that supports the Internet of Water. Next. So we're not designing this program sort of in a vacuum. We, in 2016, conducted a benefit study, a hydrography requirements and benefits study that asked questions of a variety of our partners and users across the nation. And we documented over 400 mission critical business uses for hydrography. And we found that our current hydrography data are essential to critical applications. And the current program provides about a little over $500 million in annual benefits in things like if people don't have to reinvent the wheel, we already have a hydrography mapping, so you can start from there. We also found that a modernized 3D enabled hydrography program could provide $1.14 billion annually if all the requirements were met for the program. Next. And so we're designing the 3D hydrography program to follow 3DEP. Anybody who's familiar with 3DEP, we enter into partnerships with our state, local, federal, tribal, and private entities to collect data in high priority areas, and again, to complete coverage for the nation. And we'll move forward with 3DHP in a similar manner with governance, coordinated partnerships for acquisition of the data. And we intend to add 3DHP to our broad agency announcement, which allows us to solicit funding partnerships to a broad community, and then contract acquisition of the data primarily through the USGS geospatial products and services contracts. And so one of the keys to this are, well, two keys are providing specifications so we know what we're trying to achieve, and also to standardize on a base elevation for data derivation. And that standardization is a 1 meter 3-depth DEM on CONUS, the islands and territories, and 5 meter 3-depth DEMs in Alaska, where we collected IFSAR data for the baseline 3-depth. Next slide. So I just want to quickly emphasize that as with our current hydrography data, our entire user and partner community have roles to play. USGS manages these data on behalf of our community, but we need everybody to help us with data acquisition, with governance and specifications, and with developing new and innovative technology and applications to both derive the data and also to apply applications to the data. And with that, I'll pass it on to Steve, who'll give you more details about the program.
Okay, thanks, Sue. So Sue mentioned we are launching the new 3DHP program, and the biggest single driver here is to get the hydrography data, again, much of which has been derived from topo maps or other sources, to align vertically, horizontally, and temporally with the 3-depth elevation data. We need to have a consistent set of data for national and regional applications, situations where the data density or data quality change at state lines is really problematic for a lot of applications. But this also gives us an opportunity to restructure the hydrography program to follow some of the things that we've learned in 3-depth regarding governance, regarding data acquisition, and regarding specifications. It also, frankly, gives an opportunity to really re-envision what we do with the hydrography data and move it from being a surface water data set that was largely derived from cartographic sources into a system that do a much better accounting of the hydrologic cycle, including linkages to groundwater, wetlands, urban hydrography, and those urban deserts that we have. But also provide interoperability with data sets that affect or are affected by surface water, things like the soils and land cover and superficial geology. As Sue mentioned, that much of this is driven by what we learned in the hydrography requirements and benefits study. The highest, the most important item there was that we'd be able to retain the highest level of detail available, but also build generalizations so that people doing analyses at regional, continental scales could still use the data effectively, even if it does include every roadside ditch. The other things that those next two items actually also are big drivers of this. And actually, in this one, this table identifies the percent of mission critical activities that required that attribute. But when the value of those mission critical activities was tabulated, the importance of these two items was even higher. And then you'll see some of the other items that they're driving where we're going with the program. And really, it's all about improving applications. It's fine to make a nice data set, but people need to be able to use the data set to answer real world problems. And maybe the greatest example of that recently has been the National Water Model, really reinvigorating, reconceiving the way that we model floods in the United States. And they started out with the national NHD plus medium res, working at with about 2.7 million features. And they're in the process of working towards using the high resolution data with about 10 times as many features. But they were also actively discussing, every week we're on calls with them, talking about what they could do when they actually have that generalizable detail. And so being able to understand very local flow paths, but across the context of something like the Snake River or the Columbia River or the Missouri River. And then you sort of see an example of that continental scale approach in the upper right, that sometimes that animates, sometimes it doesn't. I'm not sure why it isn't today. But you also see it at the lower right, the detail that's available in the LiDAR data that we're collecting through 3DEP. There you can see, in this instance, you see individual trees that might be flooded. But you can also see individual buildings. You would understand if a road was impassable or perhaps was passable by emergency vehicles or rescue vehicles. Or in the context of a forecast, understand how long that road would be passable. This is really vital information for emergency management applications. We also want to make sure that the 3DHP is more interoperable with other data sets. And so I spoke a little bit about the connections to groundwater, being able to understand gaining, losing reaches, places where, and other ways that that surface water interacts with groundwater. We want a much better alignment with the NWI, mapping, swamp marsh features in the NHD have been there for years, but NWI is really the authoritative source for that information. And we want to be able to work with that data interactively and seamlessly. We want to mention including engineered hydrologic systems. So these are everything from the stormwater systems under our cities to culverts that may route flow under a road, or in some cases may even route flow under another water feature. And then that last item is actually one of the most exciting items, although it's still very much developmental. That's including inland bathymetry from that next generation of 3DEP data as part of that 3D National Topography Model vision. So our transition period for this is really the next 2 fiscal years. So starting in about 6 weeks and winding up in about 2 years. But where we want to go with that in 23, we are going to implement the first iteration of the data model, and we're going to populate that with elevation-derived hydrography data. So this is data that we validated that meets the EDH specifications that were published a couple of years. And that data is a little bit sparse at the moment. We'll use a pruned version of the NHD, sort of a simplified version of the NHD, to connect that network outside of the areas where we have that data. And that'll allow applications to route water, across from, say, central Pennsylvania down to the Chesapeake Bay. In 24, we expect we'll probably still be tweaking the data model a little bit. But really, big items there are to start releasing products. So release a data service, get the markup functionality in place, get the hydro addressing capability in place, start to release some of the raster products that'll go along with this, and transition our hydrologic units from WBD to 3DHP. And I skipped over one bullet there, and that's develop criteria for pre-EDH data inclusion. We know there are a lot of states and partners out there that have been doing good updates of hydrography for a number of years based on very, very high resolution imagery data, or perhaps based on LiDAR that just isn't 3-depth LiDAR. And we want to be conscious of that and develop some criteria for bringing in those improved data sets as perhaps a provisional data set until we get data derived from the LiDAR, or really just as a matter of filling out the map with some of those good data. But they're probably going to be possibly even project specific adjustments that need to be made, probably most notably the addition of Z values to the data. But there may be other additions or modifications of the data that need to be made to make it function in a 3DHP environment. So the data model is conceptually very different from what we've used with the NHD, which is just points, lines, polygons, right? The idea here is going to be based on the OGC high features standard. And so this is really a water-oriented data model, designed specifically for hydrologic applications rather than being a sort of modernized transportation network or something like that. It includes common vocabulary to speak about water features. It also includes really as a perspective from the point of view of hydrology and water fluxes rather than maybe the construction along surface water features. This approach is being adopted in Canada as well. We're talking with them actually basically weekly on their data model, and actually have some hopes that these data sets may interact seamlessly. That would be great. But this is also the direction where, again, NOAA and the National Water Model, EPA, and USGS water science groups are moving. And we spoke about generalization capability a little bit earlier. This system also supports almost a native multi-scale rendering capability. And so that's very important here. Finally, we're really going to simplify the data set, really focus on, again, just what's hydrologically important, and allow lots of the other attributes that we currently carry as core, as different F codes within the data set. Encourage those to be carried as address data, linear events, point events, poly events, whatever. Carry them indexed to that core data set, but not as an inherent part of that core data set. And that core data set is a significant part of our challenge in maintaining the NHD. Back when we started the NHD in the late 90s, really anything, we were trying to capture the blue things off the map and sort of anything watery. And so over time, we've ended up with 22 varieties of pipelines in the data set. We got 24 different varieties of reservoirs, including swimming pools. And we've got things that are in there, but they appeared on the topo maps when the topo maps were drawn 40 or 50 years ago, but have not really been updated in any systematic way since. And these are things like lock chambers and rapids and rocks and so forth. But carrying all these features around, it's really it's a major burden for maintenance, just in terms of maintaining the tool stack that keeps these things going. But it's also a major barrier to use. People are confronted by that NHD data model, and some significant fraction of them just run scared. So we're going to use a much simpler data model with 3DHP. I hear sort of a very simple comparison. On the right is the NHD data model with, I think it's 173 different distinct F codes. On the left is what we currently use as the schema for the elevation-derived hydrography specifications. And this, we haven't finalized sort of what's in and what's out of 3DHP, but it's probably not going to be much, it's not going to be bigger than this set. It's probably going to be smaller than this set, meaning we're going to shrink this from 173 F codes down to perhaps like 15 to 20 F codes. I mentioned populating the 3DHP data set. And one of the key aspects of this is we're going to validate the data before it goes in the database. This is something that actually we've never really done before. But that's going to, using basically only having clean data in the data set means we have to do a lot less fixing and processing on it later. In this instance, starting with validated data, it gives us an opportunity to demonstrate some of the concepts, and also as we make modifications in 24 to tools and processes, maybe the database itself, doing those manipulations on a few million features is a lot easier than doing them on a couple 100 million features. And then once we get a working system that we are comfortable with, we'll evaluate those other data sources that have been generated and try to sort of bring those into 3DHP. And areas where, particularly areas where there have not been NHD updates over the years, will end up continuing to be connected by that hydrologic skeleton until we can get better 3DHP data acquired. This also changes significantly the role of stewards and steward editors, and particularly within the hydrography community. For a long time, we've relied on folks in the states to not just understand the hydrology of their state, but to actually understand how to run our edit tools and how to check things in and out of our database and how to work with 170-ish F codes. And we want to take that barrier for markups down, take that barrier for edits down considerably. And so the first place we do that is to actually validate the line work before it goes in the database, so we have less in the database that needs to be fixed. But we're also going to shift to a primarily markup environment where stewards, and this now could be fisheries biologists, it could be foresters, it could be land managers, it could be county officials, who knows. People can submit markups through a web app, look a lot like the web app we have currently. And those will be reviewed by USGS and by stewards if we have stewards in the state. But then those edits will actually be made by USGS. We won't be relying on external editors to do that work anymore. And again, that functionality is slated to come online in late 24. Another fairly fundamental shift is we're really looking at this as a services first product. We talked a little bit about the Internet of Water and being able to find locations on the stream network. People need to all be using the same version of the stream network in order for that to work. And so hitting a service facilitates that in a way that having periodic downloads just doesn't. Now, with that said, we do need to, we are going to provide annual static releases, particularly for the research community, people that need to be able to say, I used this version of the data, downloaded on this date, and these were the results I got. If you want to run it yourself, you can go get that same data set and run it yourself. Right now, we don't really have the ability to go back and get the NHD that somebody used for analysis 5 years ago. So this is our to-do list in a lot of ways. But as you can tell, we've got a whole lot going on in FY23. Some of the key portions here are really that baseline data set completion. As you may have been able to tell from the graphics Sue showed earlier, we've actually finished NHD plus high res in CONUS. There are a couple places we're making a couple tweaks, but that's done. We also are going to produce, we're going to continue to produce NHD plus high res in Alaska in 23. But at this point, In 24, we plan to shift that over to a 3DHP based product. Many of you have been dialing into the stewardship calls or the community calls, and are familiar with the new specifications. And I will probably skip over the rest of that in the interest of time. During this transition period, we are going to have to shut some things down to make some room for the new activities. So we will be accepting markups through the markup tool through the end of November, and if they're in by the end of November, we will get those implemented. After that, it becomes sort of as resources are available. But we also need to phase out NHD editing in 23 to make, to free up resources to make the new system. And so that means basically checkouts and new editor training, editing really needs to come to an end by the end of the first quarter, so December 31st. WBD editing is a little less complex, a little less intricate in terms of software. And we think we can keep that up and running until June 30th of next year. Mentioned we're going to halt NHD plus high-res production. When we get all of the markups in and all the jobs checked back in and everything tidied up, we're going to publish static versions of the NHD WBD and NHD plus high-res at the end of next fiscal year. And those will be around for a number of years going forward because it'll take a little while for 3DHP to populate. But those will be available. The services will remain active. HydroAd, for example, will continue to work against an NHD service for many years to come. And we do plan to add batch QC for lines to HydroAd in 23. And then that application will also work against 3DHP in 24. And that's the talk. So I apologize for sort of skipping through some of that at the end, but we try to, usually it runs a little long.
Well, that was great, Steve and Sue. Thank you very much. So there are a couple of questions. I've been looking at the chat line, kind of monitoring that.